So welcome to this video. Uh, this video will focus on the phase shift modulation control portion of the senior projects group's LC converter design. So I was in charge of applying phase shift modulation control to an LLC converter. And so what you're seeing on screen right now is the Simulink file for it. So some upsides of phase shift modulation is that it keeps zero voltage switching for a longer period of time in comparison to frequency modulation, which means that the efficiency when using PSM is greater. So the way that phase shift modulation works is that we have a full bridge, switch bridge right here. So at the beginning of the simulation, the diagonal MOSFETs are in the same phase, which means that, for example, if these two are off at the beginning and these two are on, they'll be on with the same phase. Now as time goes on, let's just say these two MOSFETs will be out of phase with their diagonal counterparts. So for this simulation specifically, this was designed with an input voltage of 48 and an output voltage of 12 volts, as we can see here, as I pre-ran the simulation. And then the load power will be 1 kilowatts, which I have the measurement for right here, 1000 watts, 1 kilowatts. I would like to note that this design file, this phase shift modulation control design file, is based on two other design files. So the first design file that I used helped me do the phase shift control in the gate signals, but we'll go over that later on. While the other design file is based on one of my partner's work for the Half Bridge LLC on Simulink. So all of these values here, all of this was based on his values. You'll be able to find his values and how he designed those values in his video. Also, I decided that the switching frequency would be 85 kilohertz. So the way this works is that it requires a controller to function. So, and that one was designed here. As you can see, it uses a PI to fix the steady state. And then it takes an error of what we got as an output with what we expect, 12 volts. It goes through the PI and it goes into this block. This block is designed with a D flip-flop, an S flip-flop, and as you can see, many different logic gates. And then this will make sure that QD and QC will be phase shifted. So with this, I would like to note that the input clock frequency and this sawtooth frequency right here, you're going to need to make it 2 times the switching frequency to get it to work. So the output of this is right in here, as you can see, 12 volts steady for the 0.05 seconds the simulation ran. So with that, I also would like to show you the input gate signals. Alright. So I'll show you at the beginning. At the beginning you can see A and D are off at the beginning, while B and C are on, and they're all in phase. But then I'm going to go into the very end. As you can see, A and D are out of phase, B and C are also out of phase. Now this controller design was adapted from a reference that professor forwarded me of a grad student named Antonio Manchaca. And here's what he did. He made a phase shift controller. It's worth noting that ours is LC, his was LCC. And if you want to look into this file yourself, I've left it into the drive. I will show this later on in this video. Okay. In this portion of the video, I'd like to go over the organization of the shared drive and of the work that I'm leaving behind. So in the first semester of senior project, I was in charge of researching 48 to point of load converters and finding market solutions that were currently available. There weren't too many solutions, but I have notes on some. Right here, this file right here is specifically the two, or it's a comparison of the two converters that I focused on. Here is the converter from Belfuse, the data sheet and the brochure, and a link to the website. Here is everything related to the LMG5200 reference design from Texas Instruments. And in the second semester, we moved on to 48 to 12, and we were designing for an LLC converter, which you could find all their documents here in 48 to 12. Mine specifically was, my work specifically was based on phase shift modulation control, and you could find it in this folder right here. In this folder, you'll find my design that I showed earlier in this video. In this file right here, these two files show the load and the voltage dynamically changing, so that you can see that the phase shift is working. I also have notes on phase shift. Right here are notes on videos from Texas Instruments comparing a phase shift full bridge converter with an LLC full bridge converter. I suggest watching those to get a good idea of what phase shift and what LLC full bridge does. And I also have notes based on a reference that professor gave me. Right here, the reference is found here under LLC performance enhancements with frequency and phase shift modulation control. Finally, the controller design was interpreted from Antonio's design, which Antonio's design was an LCC converter. The algorithm is the same, and you could find his design here in this folder.